Hi, everyone. So, I thought I would take some time to go through some important trig values that are going to be used with the unit circle. And these trig values all relate to the special angles that we've talked about, the 30-degree angles, the 45, and the 60-degree angles. So, when we look at the unit circle, I have it done out for us. If you don't already have that done, you might want to do that. We have all of these coordinates. And I think we talked about how each of these would actually make a triangle with a particular angle here. Now, in this case, we know this is the 30-degree angle. As we would move along, this would be the 45-degree angle. Here's our 60-degree angle, and then 90, and so on and so on. So I thought that where's my eraser? I thought that I would go through this with you and get you started on memorizing and understanding some of the trig values that we will be using, and that will be very important. You will need to memorize these, okay? Absolutely no way around it. So let's start with the ones that are a little bit more straightforward. And actually, before I do that, let's remember that the sine of an angle is equal to opposite over hypotenuse. The cosine of whatever angle we're dealing with is equal to the adjacent over hypotenuse. And of course, tangent of the angle is equal to opposite over adjacent. Now, in every single one of these, the hypotenuse is 1 because we are working with a unit circle. So, when you look at sine being opposite over hypotenuse, you have the opposite over 1, which really means that the sine of the angle is the length of the opposite side. And recall that the opposite side is always the height of the triangle. So really, it is the y value of our coordinates. Okay, so let that sink in. Sine of 30 is 1/2 because it's the height right there. In a similar way, cosine is adjacent over hypotenuse. And once again, hypotenuse is 1. So the cosine of an angle will always be the adjacent side length. So in this case, cosine of 30 would be root 3 over 2. Tangent is always going to be the ratio of the opposite side. Oh, I should have written this. Sorry. Cosine of theta is always going to be the x value. Tangent of the angle will always be the opposite side divided by the hypotenuse, which will be y, the height of the triangle, divided by x, the length of the triangle. Okay, so that's something you're going to think about as we move through these problems, as we think about SOHCAHTOA. Those are definitely things that you're going to be needing. Okay, so let's get started. Let's talk about all of the quadrantal angles. Okay, so when we deal with the 0-degree angle, we know the sine is equal to the height, and the height here is 0. We know that the cosine of the angle is equal to the x value. And in this case, the x value and the hypotenuse are the same. So we don't even have a triangle. It's just kind of collapsed onto itself. But the cosine is 1 because you're 1 unit from the center. And then, of course, the tangent will be the opposite divided by the adjacent. So the height divided by the adjacent, 0 divided by 1 is 0. Okay. If you can remember that, let's go over here to 180s. We're at the last column of this chart. We'll go to 180 degrees, and now we're looking this way on our unit circle. The sine of 180 is the height, and again, the height is 0. We're on the x-axis. The cosine is the length of the adjacent side, but also we have to remember that we give it direction. So the cosine of 180 is -1. And again, the tangent is going to be the opposite divided by the adjacent. So the height of 0 divided by -1, which is 0. Now let's look at the 90-degree angle. Okay, I'm going to leave you to do the bottom of the circle on your own. Once you know the top, you should be able to transfer that to the bottom pretty easily. So, oops. Okay, so let's talk about this. Now we're looking at a 90-degree angle. Okay, so get this column right here. So the sine of the angle is equal to the height. Well, this point has a height of 1. So the sine of 90 is 1. The cosine of the angle is equal to the x value. Well, the x value here is 0. So we have a cosine of 0. And the tangent, and this is going to be interesting, the tangent is equal to the opposite, which is 1, divided by the adjacent, which is 0. And you should know by now we cannot have a fraction with 0 in the denominator, so this value is actually undefined. So you can see that those three angles, the 0, the 90, and the 180, kind of all have similar numbers, 0, 1, -1, and undefined. Okay, and those kind of patterns are going to come up a lot where we reuse numbers. Okay, so let's take a look now, and let's look at the 30-degree angles. So when we look at this angle right here, this is a 30-degree angle. Again, let's think about sine of the angle is equal to the height. The height here is 1/2. The cosine of the angle is equal to the adjacent side length. Well, this is √3/2. So it would be √3/2 divided by 1. So it's simply √3/2. And the tangent is one we might have to calculate. Tangent, recall, is opposite over adjacent. So we would have 1/2 divided by √3/2. Oops, √3/2. Instead of dividing, we can multiply by the reciprocal. Okay, so 2 over √3. And the 2's wind up canceling out. So we now have 1 over √3. And of course, we cannot give our answer with a radical in the denominator. So we rationalize it and we find out that the tangent is actually √3/3. I'm kind of running out of space there. So if those are the values for the 30-degree angle, let us remember that 150 degrees is simply this triangle in quadrant 1 reflected about the y-axis. So we have negative √3/2 for the x value, positive 1/2 for the y value, and of course our hypotenuse is still 1. So for a 150-degree angle, we would know that the sine is also 1/2 because we have a height of 1/2. The cosine, if we were just looking at it as a triangle and not dealing with direction, it would be √3/2, but because it's going to the left on the x-axis, the cosine of 150 is negative √3/2. And the tangent, we have a negative divided by a negative, which is positive. So we actually get the same value for tangent, which is √3/3. So those two columns are very similar, aren't they? Moving right along, let's go to the 45, 90s. So when we look at this, let me erase some of this. Okay, let's get rid of all this. Okay, so when we look at this triangle, we have a 45, 90. Okay, √2/2, √2/2, and of course 1. So recall that sine is the height. So the sine of a 45-degree angle is √2/2. The cosine of the 45-degree angle is also √2/2. And the tangent is equal to the opposite side divided by the adjacent, which is 1. So root 2 over 2 divided by root 2 over 2. Very similar numbers occurring over here, okay, at the 135-degree angle. Gives us a 45-degree reference angle, right? This is 45, but this angle is 135. We get the same numbers, but we do have to remember that this is negative root 2 over 2. So some signs might change. So let's look at it. 135, this triangle has a height of root 2 over 2. The cosine of this angle is negative root 2 over 2. And the tangent, remember, is opposite divided by adjacent. We have a positive root 2 over 2 divided by negative root 2 over 2. So tangent is negative 1. Okay, so hopefully this is making sense. You can see where these numbers are coming from. I will tell you, we're kind of working through it now. We will be drawing some triangles together. You'll be practicing a lot. And then you're really going to have these memorized. You're not going to want to have to draw these triangles out eventually. You're just going to need to know these values. Okay, so let's go ahead and let's talk about the 60-degree angle. In radians, that's pi over 3. And the height here is root 3 over 2. So the sine of 60 degrees is root 3 over 2. I know that doesn't look so great, but the cosine is the length along the x-axis, and that is 1/2. Notice we're not putting anything as a decimal, right? We use these fractions. And for tangent, it will be opposite divided by adjacent. So I'm going to write this in the top right. So root 3 over 2 divided by 1/2. Okay, again, instead of dividing, we'll multiply by the reciprocal. So we'll multiply by 2 over 1, and the 2's cancel out. So the tangent of a 60-degree angle is just root 3. Now these numbers are going to be almost copied for the 120-degree angle, okay, except for the fact that some signs might be different. So let's look again. Cosine is the height. The height is root 3 over 2. I'm sorry, that was sine. I think I said cosine. That was sine, is root 3 over 2. Cosine, again, is going in the negative direction, so it's negative 1/2. And tangent, just like we did, is opposite divided by adjacent, but this time the opposite is positive and the adjacent is negative. The same math that we did up here on the right would occur, except we would get negative root 3 for the value of the tangent of 120 degrees. So I'm hopeful that this will help you to figure out the values on the bottom chart. Okay, so you can, trying to use my mouse here, you can hopefully fill these values out. Okay, you see patterns repeating themselves, except for maybe some signs. And you should really be memorizing these values. Okay, so that's your task. Have a wonderful day, everybody.